All right, here's what I want you to do. All right, a lot of this is you drawing your own diagram and reviewing all the vocab, and then me explaining what the new fact means. What I'd like you to do, go ahead and put a center in this first circle here, and we'll talk about our first fact of the day. Draw a central angle for me. Draw a central angle. Name its endpoints, please. Name its endpoints. I'll just keep mine A and B. And then I need you to draw a second central angle that looks congruent to the first one you drew. Okay, so same circle. In the same circle, draw a second central angle. Mark them with your congruent arc marks. All right, here's the first fact, and I think you guys will understand this pretty quickly. If you have two central angles that are congruent, the arcs are congruent. Okay, if two central angles are congruent, for me, that would mean, okay, if those two central angles are equal, arc AB and arc BC have to be same as well. All right. So there's one thing we can start using in our proof tomorrow. If the central angles are equal, so are the arcs. All right. And the second one just goes in reverse. If I give you, instead, take a look, if I give you the arcs are equal, and you can just mark an arc equal by a hash mark, that's fine. If the arcs are equal, so are the central angles. We can go both ways. So if you have one pair, the other pair has to be equal automatically. All good there, central angles? If I got a pair of central angles congruent, the arcs are equal. If the arcs are equal, the central angles, if I have them, are equal. All right, let's roll. Draw me a chord in this circle. Go ahead, put your center in. Put your center in first. So theorem number 2, draw me a chord. And draw me a second chord in that same circle that looks congruent to your first one. Not the greatest. So fact number 2, if the chords are equal, so are the arcs. Okay, if the chords are equal, so if I know these chords are congruent, there's my hash marks, so are the arcs. So arc AB congruent to arc CD. We'll apply all these to some algebra problems in a second and proofs tomorrow. Chords are equal, so are the arcs. Any issues? All right. Let's see what's up next. Oh, okay. Here's a good one here. All right. You don't have to draw anything here. It's already drawn. Take a look at DE and CB. DE and CB. Everyone see how I put that there were 8 units away from the center A. So if you have two chords that are the same distance, equidistant, let's use the big boy, big girl word here. Two chords that are equidistant from the center, they're congruent to each other. Okay, so since both chords are 8 units away from the center, that makes them, chord DE, congruent to chord CB. So if you have two chords equidistant from the center, they're going to be congruent to each other. And I'm not going to go over number 2 because we probably won't be using that at all. We'll be using this one. If two chords are equidistant, they're congruent. Then we got what? One more here. Ah, huge one. This is by far the one of the 4 I'm showing you right now, the one you'll probably use the most both in an algebra problem and in the proofs tomorrow. Diameter, draw it in. Go ahead, draw it in. Draw a diameter for me. Perpendicular to a chord. So draw a chord in that's going to be perpendicular to that diameter you just drew in. So draw a chord in. And there should be a little symbol you can put for me that says that they're perpendicular, right? So draw a chord in for me that looks perpendicular to that diameter. So I'll have A, B, C, D, and let's say they meet at C, B, E. And here's my symbol that says they're perpendicular, little right angle symbol, right? All right. If you have this, a diameter perpendicular to a chord, it bisects the chord. The chord gets bisected. Bisected meaning, up on my diagram, what do you know is true then? Give me something that's true if you know the chords being bisected. 5 chords being bisected, so bisected. Diameter is perpendicular to the chord. That tells me the chord is being bisected, meaning, oh, that's perpendicular. Bisects.
Oh, they're congruent.
What is? Give me 2 pieces. The chord is being bisected.
D, A, and AC.
Those are arcs. The chord is being bisected.
DE and EC.
Line segment DE is congruent to line segment EC. Yes. Huge. All right. That if you have a diameter perpendicular chord, it will cut the chord into 2 equal pieces, aka bisected. All right. I just threw a lot at you there. I got another one or no? Nope. Okay. We're going right to algebra problems. So using these facts and anything else we've talked about, using these facts, we don't have those anymore. We just get right to it. There we go. Using these facts, let's see if we can solve for x in each problem. And I'm getting you guys ready tomorrow, prepping you for tomorrow. Would you give me the circle facts or circle fact or circle facts you use to find x? Okay, here we go. Number 1 for you guys. Let's help me find x. What is the 8? The 8's, that is the whole thing. What is this whole thing? That's 8. That's a what? 3? What is that? What do we call that in the circle that I labeled as 8, a length of 8?
Chord.
That's a chord, right? Now, let me get a little more detailed on that last fact we just went over. It says a diameter perpendicular to a chord. Well, it doesn't have to be the full diameter. It can be, take a look, a partial diameter, part of a diameter. Because does everyone agree? If I just extended x here, that's a full diameter, isn't it? So more often than not, you're not going to see a full diameter. You're going to see a partial one. But that theorem is still applied here. The chord is getting bisected because the diameter is perpendicular. Just don't expect a full diameter every time. That won't happen. So everyone see that 8? It's being cut into 4 and 4 based on that theorem. And let's get that theorem written down right now so we have no problems doing it tomorrow in a proof. Diameter. And if we don't practice it, it's not going to come natural. Diameter perpendicular to a chord. What happens? So if I have a diameter perpendicular to a chord, finish it for me. What happens? 1, Anna?
It bisects the chord.
It bisects the chord. Good. And now, hey, am I looking word for word for this? No, but you should really tell me what's happening here. I'm not looking for word, just what I wrote up there. Diameter perpendicular chord, it bisects the chord. Good. Can we solve this now? All right, how are you going to find x now? Has nothing to do with circles, but we can use what? 12? There you go. But I don't get to Pythag. I don't get to Pythag unless I know this fact. All right, fill it in for me. 5, where's the x? 4 and 5 going?
So it's 4
Squared.
plus x squared gives 1 squared.
Good. You guys go ahead, solve for x. Three, when you're ready, let me know what you got for x. Good. There we go. Good work. Ready for 4? Now I'm going to push you here because I know you guys don't really know where to look or what fact to take here. So let me push you. 4, what's labeled as 6 up there? What's that called? That segment I labeled 6. That's a radius. Yep, good. So let me ask 8. What's the segment that's not labeled called? Okay. If I'm in the same circle, what do I know about all the radii? If I'm in the same circle, what do I know about all the radii? 1, Anna? Ready? Got to be 6. All radii in the same circle are congruent. So here's the theorem. In a circle, all radii, and that's radius plural, it's not radiuses. All radii, double I when you spell it, are congruent. And let me be a pain here, even though I know I've been it the entire year, and especially this unit. You got to have this in. This has to be in your theorem. Because if it's not, listen to it if it's not. All radii are congruent. So every single radii we draw is the same length? I don't think so. It has to be in a circle. All right, the same circle. All right, in a circle. All right, now how are you going to figure it out? How can I find x now? 12? I could do Pythag. Anybody else want to do something else maybe they thought about? Pythag's awesome. These are congruent. Anybody, that's a 45, 45, 90. So if you know your rules, you can do that too. But I'm doing Pythag. 6 squared plus 6 squared equals x squared. I got to change that next year. That's garbage. That I'm letting you guys do this. That's garbage because you're better than that, and I've trained you better than that. Got to change that next year. Should have said simplest radical form, right? But I let you off easy. Nearest 10th. So, yep, get the calcs out. You guys can round nice and easy. That drives me insane. You're better than that. You don't need to. Round to the nearest 10th. Nearest 10th, what are we looking at? 9? 8.5. Yeah, 8.5. Should be 6 radical 2. Okay, 5, or number 3 for you guys. How long is the one chord you already know? How long is the one chord you're given? 1, Anna, how long is the one chord there?
6.
6. Using a fact we talked about, what about the other chord then? That chord is 6, and how about the other chord? 8.
6.
Also 6. Ready? Here's how I know this chord also has a length of 6. They're both how long, how far from the center? 7 units. Here's the fact again. Chords, let's use the big word, equidistant. Chords, equidistant from the center are congruent. Oh, how do I get to x though? Let's use another one. Use another fact. Let's use another fact. Remember, hey, everyone see my right angle? I know it's not a full one, but this is a part of a diameter. So what happens between these two meet and form a right angle? What happens to my chord? 5, what's happening to the chord here? I got a part of a diameter that's perpendicular to a chord. What happens to the chord if it's perpendicular to it?
It's bisected.
Okay, so what's each piece then?
3 and 3.
Yep, so x will be equal to 6, cut it in half because it's being bisected. 3. And we used actually 2 circle facts here. Diameter. I'm going to let you guys start finishing these now. Diameter. 1, Anna, diameter.
That's perpendicular to the chord, bisects the chord.
Fine. I like it. And these are all going to go in our reasons column tomorrow. I know you're excited. Anything so far? And then it goes blank, but I know you guys have another one. Oh, and I started you off with the proof, huh? Okay. Take that one. Let me just borrow this. We'll draw this up. Awful diagram. And there should have been, is there a right angle symbol there? Yep. Sometimes you may have to add in a little extra. What I give you is not good enough. Right? You may have to add in a little extra right now. Is there anything you could tell me is happening in this diagram? Okay, Spence, what's happening? All right, awesome. Chords being bisected. So maybe if you could find one half of it, you could just double it to find x, right? If I could find this piece or this piece, I would just double it and find x. Well, there's a reason I gave you the 3 too. What is 3 in this diagram? That's the what of the circle? 8 radius. So if I happen to draw another radius in, how long would it be? 3. Everyone agrees? It would also be 3. Is there another radius I would be able to draw in that might help me find either one of these pieces? Everyone seeing it? Draw it in. Good. Draw in that other radius you think would help you out in this problem. And you already know how long is it? 3. Yeah. So I could draw that one in. I could draw it going to the other end as well. Here's 3. And then how can you guys find this piece here so I can double it? How am I going to find that piece I need to double? 13? Pythag, yep. We'll do the theorems here at the end. Let's just find x first. So 2 squared plus b, the leg squared, and the hypotenuse is across from the right angle. That's going to be 3 squared. Move the 4 over by subtracting it. B squared equals 5. So you end up with the square root of 5, which is not my, you can go to your calculator and find it, but don't round it, right? Because that's not my final answer. That's not my final answer. X will be 2 times whatever that is. So 2 times radical 5. Then I want to round. Don't round it until the end, though. And nearest tenth, as the directions say here, 1. Anna, what do you have?
4.5.
4.5. Okay, we went over, you guys plug them in now. 2 theorems here. 2 theorems for the box. First one was, Spence gave it to us. I put those congruent marks there. Why? Why did I put the congruent marks on the chord? 13, why did I put the congruent marks there?
Because the diameter perpendicular to a chord bisects.
Awesome, awesome, Charlie. Diameter perpendicular to a chord bisects the chord. And I get it, guys. This is tedious, but it'll help out so much tomorrow, and you'll get a little taste of tomorrow on this next problem. And also, there's another circle fact I used. Remember, I drew in that other segment there, and I knew it was 3. Why? How did I know that other segment was 3? Ooh, 2.
All in a circle, all radiuses are
There we go. I got to have in a circle. That's non-negotiable. In a circle, all radii are congruent. Good job, everyone. Good job. Should we have a ceremony right now? Moment of silence, pass out tissues. Go ahead, go to the next one. Welcome back, everybody. Welcome back. I didn't want you guys to be, I don't want this to be too harsh, so I did the statements, reasons there for you. We got to prove angle A congruent to angle C. All right, I know it's been so long. Those angles won't be congruent unless what are congruent first? Nothing to do with circles. Just think back to your triangle days. Those angles won't be congruent unless we prove the triangle's congruent. Correct. You know, all those 5 methods, CP, CTC at the end. All right, so help me get those 5. Help me get those triangles congruent. See if you can find anything you know is true here as I put this up on the board. See if you can find anything that's true. Mark it on your diagram. You may not know how to write it in the reasons column, but at least mark it on your diagram. There should be something you can at least mark in the diagram that gets those triangles. And it doesn't have to be a circle fact either. Remember, anything we've done this year, fair game. Oh, and I gave you B as the midpoint of arc AC too. Wow. Okay. And I'll let you know there's more than one way to do this proof. More than one way to get those triangles congruent. I don't care if it's a circle fact or not. Tell me something that's true up here. All right, whether it's a circle fact. Remember, I'm trying to get the triangles congruent. 4. Give me something that's true. Of course, he goes right to that, right? QB congruent to itself. Reflexive property. Good, so that gives me a pair of sides. All right, unfortunately, now you're going to have to go circle facts. Or you can use the given, too, that B is the midpoint of AC to give me something that's true. Give me something else that you think is true. Or maybe you don't think it. 9? Yep, arc AB has to be congruent to arc BC because of that given definition of, Eleanor? Yep, definition of a midpoint. Good work. So now I know the arc, not the sides, the arcs are equal. Not the sides of the triangle, the arcs. Now, does that get you anywhere? Or do you see anything else? Come on, keep grinding here. We got a couple minutes left. 12, anything else?
Well, you know that chord AB and BC are congruent.
Let's go. If the arcs are congruent, so are their chords. Perfect. Nice job, Rachel. AB, line segment AB, congruent to line segment BC. And here's what I'll have you write. Congruent, what did we already know was congruent? The arcs. So we'll start out congruent arcs. Imply, remember our arrow. Congruent. What did you just tell me were congruent, Rachel? The chords. Correct, chords. Congruent arcs imply congruent chords. There's what? Another pair of sides. How about QA and QC? What are those? Everyone always overlooks those, but they're staring right at you. One, Anna, what do I call QA and QC?
Radii.
And if they're in the same circle, they're always, there you go. QA congruent to QC in a circle. All radii congruent. And I think you guys can finish this up, right? What's the method going to be for my triangles? 7. How can I get these congruent? What was the side, and then you're going to finish it off with CPCTC. Angle A congruent to angle C. Just wanted to give you guys a little taste here today. And was it out of the book tonight? Okay, yep. Only 8. Whoa! 4 problems. I gave you a hint for number 17. Try to draw a right triangle out of it. All right, 4 problems. Get after it tonight, please. And then tomorrow is strictly, I believe, just proofs, getting after it.